So today we are going to start looking at how to graph trig functions. And we're going to start with a little video that explains where some of these points come from. All right, this will explain where some of the points come from on the graph. Okay, notice that we have a circle. Okay, we have a circle, and if you look at the top and bottom, okay, its radius is 1. Okay, and we have the opposite over hypotenuse ratio. We have the adjacent over hypotenuse and opposite over adjacent. We do have all of those values. Okay, watch and listen.
Okay, guys, I want to provide you with one more GeoGebra link, which is creating the graphs of the sine, cosine, and tangent by unwrapping the unit circle. So, of course, what we're doing here, we're going to say, let's form the sine graph. Okay, so as we move counterclockwise around the unit circle, we follow the height of the y segment. The length is CD.
Okay, take a look at what's going on right here. Okay, this red is going to be the graph of sine of x. Okay, we are moving this blue point around the circle. Notice the height. The height of that point is the height of the red line, the red curve, the sine graph here. Okay.
As a function of this angle, and we see it sweeping out, forming the graph of the sine. Okay, now when we are at pi over 2 radians, that is, of course, 90 degrees, the y value, or the sine, is taking on its greatest value. Okay, then it's going to start declining, all right, until it comes back down to 0 at a half a revolution, or pi radians, and taking on its lowest value down here at -1 when we swung around a full 270, or 3 pi over 2 radians, and then back to its starting point, having run through one full period, one full revolution, okay, of 2 pi radians, okay?
So that's what we call one cycle of the sine graph. We went one revolution around the circle, and at every angle measure, we plotted the height of the point around the circle. Okay? Or you keep going.
Okay. Now, if we want, we can also look at generating the cosine. Of course, the cosine is going to be concerned with following the value of the x-coordinate of this point in question, which, of course, is this length here, AD, our length here, AD, which starts out at its greatest value of 1. And as we sweep around the unit circle counterclockwise, and that angle changes at this point, 0.71, we're going to be approaching pi over 4, okay? So here we are right about at pi over 4. Then when we hit pi over 2, or 90 degrees, we're at 0. Then the cosine dips negative, because the x values take on negative values there, until it reaches its lowest value here at pi radians of -1. Okay, working itself back up to 0, okay, and then coming back to its starting point where it started with a value of 1. There's our graph of our cosine. So this applet is really convenient and does explain how the unit circle is used to generate the graphs of the sine, cosine, and as well as the tangent, which of course we'll look at later. So look at that and learn from it, okay? It's a very valuable tool for you.
So that graph, that little video applet went through for sine, it went through the height of the point all the way around the circle. And for cosine, it used the width, the x value of the point all the way around the circle. Okay, so this blue, darker blue curve is what the graph of cosine x looks like, and that is one cycle of the graph. Okay. All right. Yes, I know. We are going to look right now at how to create these graphs. And what everything means on those. And we are going to relate that to the unit circle that we've been studying. So if you'll look on the 7-1 lesson, the link to that video I just showed you is on, is this YouTube link. Okay, I just showed you that video. So we're going to start by graphing sine of x. Okay, and we are going to use the unit circle in order to help us do that. Okay, so we're going to do the positive values first. We know 0 is on the right. Okay, we're going to do this one in degrees. We're going to do another one here in a little bit in radians. Okay, which way do we rotate if we're going positive? The chat is open. Yes, we rotate counterclockwise. So up is 90 degrees. Left is what? Pardon me. Left is 180. Down is 270. And the right is equivalent to 360. Yes, good job, y'all. Thank you to those of you who are putting answers in the chat for me. So if we look at these, we want to find sine. Okay, we know that sine of an angle is its opposite over hypotenuse. If we put that in terms of x, y's, and r's, the opposite is x or y. Opposite always is your y. Sine is y. They have that same vowel sound. The hypotenuse we know is r. For on the unit circle, this circle, r is 1. So sine of an angle is just its y value. Okay, the y value of the point on the unit circle. Okay, so with a radius of 1, what's the point on the edge of the circle here? What are its coordinates? We have the xy axis. 0, 0 is at the center of the circle. Radius of 1. So at the end of the circle, we are 1 unit right. And yes, that is 1, 0. Okay, so at 90 degrees, what is the point at the edge of the unit circle? What are its coordinates? 0, 1. Yes. Okay, what about on the left? What's 180? Negative 1, 0. Okay, and 270 would be 0, negative 1. They're your coordinates. Okay, those are the xy values that we can use here. Okay, so really big, really, really important, sine of 0. Sine of 0 is the y value of the point at 0. Sine of 0 is what? Sine of 0 is, what's the y coordinate of the point that represents 0? 0 degrees. You're making this too hard. At 0 degrees, the ordered pair is 1, 0. Ordered pair is 1, 0. What is the y coordinate there? 0. Yes. So sine of 0 is 0. Okay? Everybody give me an answer in the chat, please. What is sine of 0? All right, 3 people did it. 4 people did it. Okay. Everybody unmute and tell me. Sine of 0 is?
0.
Thank you. Thank both of you. Yes, everybody. Sine of 0 is? Sine of 0 is? 0. Okay. Sine of 0 is 0. That's really, really important. Okay. So we are going to use those positive angle measures, and we are going to find sine of each of these angles. How do we find sine? It's what coordinate? Sine is what coordinate? Is sine x or y? It's y. Yes. Okay, sine is y. So as we look at each of these measures, we're going to look at the y coordinate of the point. Okay, so sine of 0 is 0. We've got that one. Sine of 90. What's the y coordinate of the point at 90? 1. Sine of 90 is 1. What's sine of 180? What's its y coordinate? 0. What's sine of 270? What's its y coordinate? -1. That is a negative, not something different. And then what about 360? 0. Okay, good. Now, we need to number these angles backwards. Okay, we need to number these angles. Sine is y because it's opposite over hypotenuse. Okay, when we are on a coordinate plane, okay, standard triangle, we have our angle in the quadrant. We draw the perpendicular to the x-axis. One leg is on the x-axis. Theta is in the corner at 0, 0. Hopefully you've remembered that speech from most lessons so far. Oh yeah, another number almost like mine trying to call me. Woohoo. All right, so as we label this triangle, okay, because theta is always in the corner at 0, 0, the y is always the opposite. The x is always the adjacent. This point, x comma y, that opposite is y, that adjacent is x. The hypotenuse is the radius of the circle, and on the unit circle, that radius is 1. Okay, so sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Over here on the left of my screen in blue, sine of x is opposite over hypotenuse. Opposite is y, hypotenuse is r. R is 1 on the unit circle, so sine is y. Okay. Same thing, y cosine is x. Okay. Same thing, y cosine is x. Now, we need to use the negative angle measures, okay, to do the other portion of this. So when we do those negative angle measures, okay, which way do we rotate when we go negative? Which way do we rotate when we go negative? We do rotate clockwise. Okay, so rotating clockwise feels like it should be normal, but it's not on angles. So when we rotate clockwise for the negative angles, straight down is negative what? Straight down is negative 90. Then left would be negative 180. Okay, then top would be negative 270. Okay. And again, on the right would be negative 360. Okay. So again, we want the y coordinate for each of those. Okay. So at negative 360, that y coordinate was 0. At negative 270, our y coordinate is 1. At negative 180, that y coordinate is 0. Okay. At negative 90, that y coordinate is negative 1. Okay. Just using the y coordinates there. Now, what we want to do with this is use these points we just found, and we want to plot the graph of sine x. We want to plot the graph of sine of x. Okay? Everybody unmute for just a minute. Sine of 0 is 0. Say it again. Sine of 0 is 0. Okay? So when we're labeling our x-axis, we're labeling this in degrees. Okay? We're going to have 0 degrees here in the middle. That's degrees, not squared. Okay? Then we're going to count by the quadrants. So 90 degrees, 180 degrees, 270 degrees, 360 degrees. Okay? Then on the negative side, negative 90 degrees, negative 180 degrees, negative 270 degrees, and negative 360 degrees. Good? Okay, sine of 0 is what? Sine of 0 is about 3 or 4 of you. Sine of 0 is 0. Okay, so at 0 degrees, sine graph is at 0. Okay, now we're going to use the rest of these points to plot what we need. Okay, at negative 360 degrees, sine is 0. Okay, at negative 270 degrees, sine is 1. At negative 180 degrees, sine is 0. At negative 90 degrees, sine is negative 1. Sine of 0 is 0. Sine of 90 is 1. Sine of 180 is 0. Sine of 270 is negative 1. And sine of 360 is 0. Okay, all of that from those points up above. That'll work. Maybe not. Okay. So for labeling our y-axis, obviously 0. What's this top line? What's its y value? It's 1. And on the bottom, that is negative 1. Okay. So when we connect this graph, it is a smooth curve. Okay. It's not pointed. Okay. You kind of saw on that graph on that video earlier. Okay. Makes a nice curve. And it doesn't actually stop. It does keep going. Okay. It does keep going. Okay. This is your graph of sine of x. Using the y coordinates around the unit circle, here are the graphs. Okay. So from the center horizontal axis, straight across, that center line straight across, how far up or down does the graph reach? From the center axis, how high up does the graph reach? Just 1 unit. Yes. And how far down does the graph reach? That is also 1. So it is 1 unit is our maximum, and then 1 unit down is our minimum. Okay? Now, take a look at this graph and figure out how many degrees it takes for the graph to go through 1 complete cycle. How many degrees does sine of x go through 1 cycle? Put your best guess in the chat. If it's wrong, I won't tell anybody it was you. All right, a couple of you've got it. How many degrees do we think it takes to go through 1 cycle, 1 complete cycle of this graph? If you're looking at my answer key, it's already there as well. It is 360 degrees. 1 cycle is 360 degrees. Okay? From 0, we started at 0. Sine of 0 is 0. It went up, went back down all the way through to negative, and came back up to positive. So this is 1 cycle, 360 degrees. Okay? Then also the other cycle, negative 360 to 0, is 1 cycle. Okay? So when we graph these, we'll be graphing most of the time 2 cycles. So you'll have 2 of those curves attached. Okay? We doing okay so far? Feel free to put questions in the chat. All right. So on the next page, we're going to do a very similar thing, except we're going to do this with cosine. Okay? Remember cosine, if we are on the coordinate plane, okay, cosine is adjacent over hypotenuse with theta in the corner at 0, 0. Your adjacent is the x. That hypotenuse is 1. Okay, so cosine is the adjacent. We'll have a point, xy. Okay, if the hypotenuse is 1, cosine is x, because x over 1 is x. Okay, so let's think about numbering this graph again. We're doing this in radians this time. Okay, we know 0's on the right. What's on the left? Actually, want a point there. Okay, 0 radians is on the right. What's on the left? What's on the left over here? Pi. Pi is on the left. Okay, what's up top? It is half a pi. How do we write that? Yes, pi over 2. Okay, so what's on the bottom? 0, 1 pi over 2. Think of this as 2 pi over 2. So next would be 3 pi over 2. Okay, and then the right wraps back around to equal 2 pi. Okay. Now, if we are looking at those points again, okay, if we're looking at those points again, we have a radius of 1. So on the right, that ordered pair is 1, 0. Yes. Okay. Up 0, 1. Left would be what? Yes, negative 1, 0. Okay, on the bottom, 0, -1. Okay, so cosine is the x value. Really big, really important here. What is cosine of 0? Here's our 0, x, y. Cosine is what here? Cosine is 1. Okay? Cosine of 0 is 1. Cosine in general on the unit circle, cosine is x. Okay? So cosine of 0 is 1. Okay? Everybody put in the chat, what is cosine of 0? Everybody unmute and tell me. Cosine of 0 is... Unmute. Cosine of 0 is...
0, 1.
Ooh, conflicting answers. Cosine of 0 is... 1. What is sine of 0? 0. So cosine of 0 is... Sine of 0 is... Okay. So going around, okay, we're going to do the same thing we did earlier with the sine graph, but we're going to do it with cosine this time. So we're looking at the x coordinates. Okay. We know cosine of 0 is what? 1. Good. Okay. What's cosine pi over 2? What's that x coordinate? 0. Cosine of pi is -1. Cosine 3 pi over 2 is 0. And cosine of 2 pi is the x coordinate 1. Okay. Now, if we number this axis going in the negative direction, okay, negative is clockwise, so 0 stays 0. Bottom would be negative pi over 2. Left is negative pi. Top is negative 3 pi over 2. And right is negative 2 pi. Just rotating clockwise with negative values then. Okay, so cosine negative 2 pi is the x value at that point. That's 1. What's cosine negative 3 pi over 2? Cosine negative 3 pi over 2. It's the x value at that point. It's that 0. Okay, cosine of negative pi, use that x coordinate. It's -1. And cosine negative pi over 2 is on the bottom. That x value there is, and yes, that's 0. Okay, so there's the points for the cosine graph. Okay, there are the points for the cosine graph. Tell me again, what is cosine of 0? It's 1. Okay, cosine of 0 is 1. So let's, whoops, sorry about that, y'all. Oh, now, of course, I have to find it again. Cosine of 0 is, quit doing that. Cosine of 0 is 1. Okay, cosine of 0 is 1. Oh, labeling this in radians, we'll have 0. Okay, pi over 2, pi, 3 pi over 2, 2 pi. Then going left, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. Okay. Then cosine of 0 is 1. Cosine pi over 2 is 0. Cosine pi is negative 1. Cosine 3 pi over 2 is 0. Cosine 2 pi is 1. And there's one of our cycles. Okay, going backwards, cosine negative pi over 2, 0. Cosine of negative pi is negative 1. Cosine negative 3 pi over 2 is 0. And cosine negative 2 pi is 1. So again, on the y-axis, we have 1 and negative 1. Okay, and here's our graph. Okay, again, just like sine, it curves. It's not a zigzag. Okay, do not connect it with V's or W's. Okay, and it doesn't actually end. It does keep going. And again, here we've got a couple, as in 2 cycles. Okay, so from the center horizontal axis, how far up or down does the graph go? Again, that is 1 unit. Okay, 1 unit there. And how many radians does it take for a complete cycle? So again, we have 1 cycle on the left. Okay, and we have another cycle here on the right. Okay. So how many radians does it take for the graph to go through 1 cycle? A couple of you've got it. If you think you know it, put it in the chat. Good. It's 2 pi. It's 2 pi radians. Okay. So the graph of cosine also takes 2 pi radians to complete a cycle. What is 2 pi radians if we convert it into degrees? If we convert 2 pi radians into degrees, that is 360 degrees, yes. Okay, so the time it takes for cosine and sine to make 1 complete cycle, okay, is the same value, 2 pi radians or 360 degrees. Okay. All right, look at the cosine graph and look at the sine graph. Are they similar? Are they similar? If I was really fancy, I'd be able to map both of those on the same screen, but I'm not. But what I can do is draw it. Sine of 0 is 0. And then it rotates from there. So this red is the sine graph. Are these graphs similar? What do you notice? Do they have the same shape? They definitely do. Okay, they have that same curve. That is called a sinusoidal curve. Okay, that is a sinusoidal curve for either one of those. Okay, they both take 2 pi radians or 360 degrees to go through 1 cycle. And both graphs go up or down from that center horizontal axis 1 unit. So these graphs do actually have a lot in common. What do you think is the biggest difference between those 2 graphs? What do you think is the biggest difference between those two graphs? Starting point. Yes, starting point is key. Okay. What is, everybody tell me, what is sine of 0? 0. So sine of 0 is 0. What is cosine of 0? Cosine of 0 is 1. Okay, sine of 0 is 0. Cosine of 0 is 1. So where these graphs start is the key difference between them. Okay, good. All right, I'm going to undo that sine graph before I save this copy. Okay. All right. That's it for the notes of our lesson today.